Today we're going to be talking about inequalities and their graphs. First, we're going to go over a couple warm-up problems just to review which sign is greater than, less than, or equal to, and what they mean. So 4 and 6, if I were to compare those two numbers, I know that 6 is bigger. That means 4 is smaller. So 4 is less than 6. Notice the alligator mouth is eating the bigger number. Okay, and then I have negative 8 and negative 2. A lot of people want to say negative 8 is bigger, but it's actually negative 2. In negative world, everything is opposite. So actually negative 2 is bigger than negative 8. So that means negative 8 is less than negative 2. The square root of 4, well, the square root of 4 is actually equal to 2. Because I know that 2 times 2 is 4. So the square root of 4 is 2. That means these two things must be equal. Okay, moving on to the lesson. So section 7.5, inequalities and their graphs. What is an inequality? We'll start with that. So it's a statement that two expressions are not equal. Okay, it's either one expression is bigger or smaller than the other. Now, when graphing inequalities on a number line, an open dot, so an open circle, kind of like an O, means that the number is not a solution. So whatever number you put the dot on, if it's open, that number is not part of the solution. So when we see these two signs, a greater than or a less than sign, we put an open dot when we're graphing. We'll practice that in a minute. A solid dot, or a closed dot, means the number is a solution. So if you see greater than or equal to, or less than or equal to, that's when you put a point on the number, that is included as part of the solution. So you can graph an inequality on a number line. Let's do that. So it says graph each inequality. A is less than or equal to negative 2. Okay, so I'm going to draw a number line. I'm going to put negative 2 in the middle since that's the number I'm focusing on. And then when I do a number line, I'm not too picky about, starting at 0 and doing a ton of numbers. As long as you put one number on each side of the number you're looking at. So I'll put like negative 3 and negative 1. So remember, we count backwards in negative world. That's fine. A line is continuous, so this goes on forever and ever in both directions. So 0 would be here, 1, 2, 3, 4. But we don't have to include all those numbers. Now, it's a less than or equal to sign. So look up here. I'm going to do a closed dot when it's this symbol. Closed dot. Now, so A is representing all of the solutions that this picture is representing, basically. So all of my A's, or all of my solutions, I want to be smaller than or equal to negative 2. So less than means this way on the number line. All these numbers over here are less than negative 2. So I'm going to darken that on my number line. Okay, and that means every single number this way on the number line is part of the solution. If I said A was negative 4, that would work because negative 4 is less than or equal to negative 2. Okay, moving on. I'm going to put, so G is greater than negative 6. So negative 6 I'm going to put in the middle. I'm going to include two other numbers. If I'm counting, it's negative again, so this is going to be negative 7 and negative 5. It's a greater than symbol, so if I have a greater than or a less than symbol, it's an open dot. So negative 6 is not part of my solution. If this G had been a negative 6, this would not be true, because negative 6 isn't bigger than negative 6. It's equal. Now I want all the G's, or all the solutions that are bigger than negative 6. So I'm going to shade this way. Now a trick to remember, if your variable comes first in your inequality, the inequality sign points in the direction that you're shading. So it's pointing to the right here, or shading to the right. That only works if your variable comes first. Okay, let's do x is greater than or equal to 3. So I'm going to put 3 here, 2 goes there, 4 goes there, 2, 3, 4. when I have an or equal to, I shade my dot. It's a closed dot. And I want all the x's that are greater than 3. So greater means all the numbers, as you go right on the number line, the numbers get bigger. So I want these solutions. Again, my arrow is pointing to the right, and so is my shading. Okay, let's move on. It says, state whether the end point of the graph of each inequality would be a solid dot or an open dot. So in other words, just look at the sign, and if I were to graph it, would I do an open or closed dot? Okay, this is greater than, so that's one of these two. That's going to be open. Less than or equal to, whenever I have the or equal to, it's closed. Less than is open. Didn't even have to solve it, I just am looking at how I would graph it. Okay, now these, I'm going to give you the graphs, and we're going to try to write an inequality for these. So let's say my graph looked like this. And this one looked like this. Okay, so let's say we were given that, and we now have to write an inequality. So we're basically doing the opposite of what we did up here. Here we were given the inequality, we had to graph it. Now we're given the graph, we have to write the inequality. So you can pick any variable you want. The most common one is x. So I'm going to do x. And now what x's are included here? So looks like there's a 3 involved. That's going to be my number over here. I just have to look at, or I have to think about what my sign is going to be. Well, I notice it's an open point. That means it's either going to be greater than or less than, not equal to. And all of the solutions I shaded were smaller than 3. So x is going to be less than 3. It's pointing in the same direction that is shaded. So this is my answer. Okay, let's use x again. Why not? And it looks like my point is on negative 11. I just have to think about which way my sign is going to go, and if it has a line under it, like if it's an equal to. So it's a closed point. That means it's going to be something or equal to one of these two symbols. Okay, and I noticed that it's shading to the right, so that means all these solutions are bigger than negative 11. So x, my solutions, are greater than or equal to negative 11. Again, notice my inequality sign is pointing in the direction that's shaded. Moving on. Oops. Okay. Example 4 says, write an inequality for each sentence.